Good morning, good afternoon, good evening, everyone. Today I'm going to talk about an interesting paper that I found. I was Googling geology papers and then I came across a production paper, so might as well talk about a little bit about engineering at the end of the day. It's generalized extreme value statistics, physical scaling and forecast of oil production from all vertical wells in the Permian Basin. If you're ever curious about what's been the total production to date in the Permian Basin. This is written by a few folks from the University of Texas. As usual, before we get to the content, please be sure to like this video, subscribe so you can get more content in oil and gas and professional development topics, and please be sure to comment on the video below so I can incorporate your feedback into future videos. Thank you so much, and let's get to the content. The objectives of this paper is to analyze nearly 500,000 vertical wells completed since the 1930s in the most prolific petroleum province in the U.S., the Permian Basin. This is to apply physics-guided, data-driven forecasting approach to estimate the remaining hydrocarbons in these historical wells and the probabilities of well survival. The methodology is a cluster of production data and set into 192 spatial temporal well cohorts based on 4 reservoir ages, 6 subplays, and 8 completion date intervals. In each cohort, they applied the generalized extreme value statistics to each year of oil production from every well in this cohort, obtaining historical well prototypes. Then they derive a novel physical scaling that extends these well prototypes for several more decades. And they calculate the probabilities of well survival and observe the vertical well in the Permian can operate from 10 to 100 years depending on the subplay and reservoir in the well to which the well belongs. They estimate the total field production of all existing vertical wells in the Permian by replacing historical production from each well in its prototype. Then they shift and sum up these prototypes together, obtaining 34 billion barrels of oil, estimated oil ultimate recovery. The most notable finding is that the rate of finding of big reservoirs in the Permian has been declining drastically and irreversibly since the 1970s. Today, operators need to drill wells that are twice as deep as the 1930s wells, yet they produce 4 to 12 times less. Here's an overview of oil rates of various vertical wells, and this is color-coded based on the decade in which the well has started producing. You'll notice that there's been an aggressive decline in the vertical wells, the more recent that's been completed. Here's an overview of where all the vertical wells are located, where each vertical well was completed based on the decade, and then the reservoir age of this particular well as described in the paper. The paper doesn't describe necessarily if there was commingled production from different reservoir ages. How was that reconciled? Paper doesn't go into detail of that. But I had to put this slide in here because what is a presentation about generalized extreme statistics if I don't put a slide of GEV? I wasn't going to go too much into detail of the GEV, but here's a slide describing it. This is a procedure of arriving at a historical well prototype using GEV statistics. Each row shows a different sampling of annual production after the first, second, and nth year production. The first column is the probability density function of annual production fitted with the log normal distribution and the GEV distribution. The corresponding C, mu, and sigma are fitting parameters of the GEV distribution. The second column shows the maximum likelihood estimate 95% confidence interval for mu and sigma. The third column displays the cumulative distribution function, including the lower bound P90, median P50, displays the cumulative distribution function, and the upper bound P10 with its confidence interval. The last column shows the resulting historical well prototype, which is constructed by connecting the expected GEV value means of each row. This next slide shows a survival probability plot of the Permian region, Central Basin, Leonardian, and then Midland Basin, Wolfcampian. So the first plot to the left is the Central Basin platform, and then the plot to the right is the Midland Basin. You'll notice that the declines get more aggressive as the vintage gets more recent. Here are the actual and forecasted rates for all vertical wells. This is how they came up to 34 billion barrels of oil that's already been produced, or that is projected to produce. So in conclusion, they provided a transparent hybrid method of forecasting conventional oil production at the Permian Basin scale. A combination of GEV statistics and very large data sets with physical scaling matches historical production data almost perfectly and gives a smooth, optimal prediction of future least square in the least square sense. Spatial temporal well cohorts are a combination of different reservoir ages, subplays, and completion date intervals. The estimated ultimate recovery from all 484,759 existing vertical wells in the Permian Basin is about 34 billion barrels of oil. They've observed that vertical wells in the Permian can last between 10 and 100 years, depending on which subplay in the reservoir and where these wells penetrate. In practice, no large reservoir has been found in the Permian since the 1970s, and today operators need to drill wells that are twice as deep as the 1930s wells, but that produce 4 to 12 times less. That's all the content I wanted to share regarding this presentation. I'll provide the link to the presentation so you can download the paper. As usual, please be sure to like this video, subscribe so you can get more content in oil and gas and professional development topics, and please be sure to comment on the video below so I can incorporate your feedback into future videos. Thank you so much for taking the time to watch this video, and I'll see you in the next one.